Hi guys, so today we are continuing on sequences, and this time we are talking about one type of sequence we have, which is our arithmetic sequences. Okay, so let's start off with our toolbox. So arithmetic sequences, what they do is they add or subtract a constant number, and this is known as the common difference. So key thing here, arithmetic sequences, we add or subtract. It has to be the same number, okay? And this number is known as our common difference, okay? What we know is arithmetic sequences are related to linear functions, okay? I kind of talked about that last time when we did that example where I kind of talked about slope when it was consistently adding by 2, all right? So for example here, we have a sequence 2, 5, 8, 11. What you should notice is that it adds 3 every time, okay? And since it adds 3 every time, its common difference is 3. So D equals 3. Right? So 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, so on and so forth. Right? Here's another one. We have 7, 3, negative 1, negative 5, so on and so forth. What you should notice is about this sequence is that it adds negative 4 every time, or another way to think about it is subtracts 4 every time. As a result, the common difference is negative 4, right? 7 minus 4, 3. 3 minus 4, negative 1. Negative 1 minus 4, negative 5. Okay? So there are 2 ways to write arithmetic sequences. One is the explicit formula, okay? And it follows this pattern. A sub n, which we know as any term, is the first term plus the common difference times the index minus 1. Okay. And so let me just highlight how I got all of this stuff. Okay, so any term that's shown here, a sub n, equals the first term, which we know is a sub 1, plus the common difference. So the common difference here is represented by d, so plus d times the index minus 1. All right. Versus the recursive formula here is any term is the previous term, did I spell previous wrong? Okay. Previous term plus the common difference. Right. So again, how did I get that? A sub n, any term. Okay. Previous term is this, right, which we talked about last time, is a sub n minus 1 tells me the previous term, and it is the plus the common difference. Okay. Know how the explicit formula, as long as we know which position we want, we can find it. Okay. The recursive formula is we need to know which one came before in order to get it. Okay. So first here, we need to determine whether each sequence is arithmetic. Okay. So that means it needs to add or subtract a constant number. Okay. So arithmetic means add or subtract a common number, a constant number. Okay, that's what makes it arithmetic. Okay, and then if so, we're going to find what that common difference is. Okay, what it is that we're adding or subtracting, and we're going to find the next 2 terms. Okay, So let's see here. Okay, so 20 to 14, what happened? I subtracted 6. Okay. 14 to 8, what happened? I subtracted 6. Okay, 8 to 2, what happened? I subtracted 6. Am I adding or subtracting a constant number? Yes, I am. Each time I am subtracting 6, so that means this is arithmetic. Okay, what is this constant number known as the common difference? It is negative 6, so my common difference here is negative 6. Okay, to get to the next one, I would just subtract 6, right? 2 minus 6 is negative 4. Negative 4 minus 6 is negative 10. So now I just have the next two terms as well. Okay. So let's try the next one here. Okay. So 8 to 12, what happened? We added 4. 12 to 16, what happened? We added 4. Okay. 16 to 21, what happened? Oh, we added 5. Are we adding or subtracting a constant number? No, we are not, right? The first couple times we added 4. This time we added 5. So it is not arithmetic because we are not adding or subtracting a constant number. Okay. Let's try this one. Okay. 15 to 22, what happened? Oh, we're adding 7. 22 to 29, oh, we're adding 7. 29 to 36, oh, we're adding 7. Is this arithmetic? Yes, it is. Okay, the reason why is because we are adding a constant number. This constant number that we are adding is 7, so my common difference is 7. To get my next term, I just need to keep going, right? 36 plus 7 is 43. 43 plus 7 is 50. And now I got my next two terms. Okay. So let's flip here. Okay. So what happens if I have an arithmetic sequence, okay, but I'm missing some terms? I need to figure out what it is. Okay. So how we do that is we take our total difference. Okay, what that means is we take our last term and we subtract our first term. Okay, please know this is important. Okay, it doesn't matter which one's bigger, which one's smaller. It's always last term minus first term, and we divide it by the number of terms. Okay, and that is all terms minus 1. Okay, so let me just highlight stuff so we remember. Okay, so the difference is going to be our total difference, which is last term minus first term, divided by the number of terms we have. And that is all terms minus 1. Okay, once we have that, we can just fill in the blank. Okay, so let's do that. Okay, so we're going to do our last term minus our first term. Okay, so negative 18 minus 36. Okay, last term minus first term. Okay, so that's why it's negative 18 minus 36. Okay, divided by the number of terms. Okay, so here I have 1, 2, 3, 4, 5, 6, 7 of them. Okay, so 7 terms. Okay, minus 1. Okay. Negative 18 minus 36 is negative 54. Okay, 7 minus 1 is 6, so negative 54 divided by 6 is negative 9. So my common difference here is negative 9, which means from 36 to my next term, I'm going to subtract 9. Okay, so 36 minus 9, 27. Okay, then I'm going to subtract 9 again. 27 minus 9, 18. Okay, subtract 9 again. 18 minus 9 is 9. Subtract 9 again. 9 minus 9 is 0. Subtract 9 again. 0 minus 9 is negative 9. Subtract 9 again. Oh, look, that's negative 18. That is my last term. Okay. So now let's try this one. Okay, it's going to be our last term minus our first term. So here, 22 is our last term. Negative 8 here is my first term. So I'm going to do 22 minus negative 8. Okay. divided by how many terms I have. So 1, 2, 3, 4, 5, 6, 7, minus 1. Okay. So 22 minus negative 8, hopefully we know minus negative is plus. So that means 22 plus 8, that gives me 30. 7 minus 1 is 6. 30 divided by 6 is 5. So this tells me my common difference is 5. Since this is positive, that means to go from the first one to the next one, I'm going to add 5. Okay, so negative 8 plus 5, negative 3. Negative 3 plus 5, 2. 2 plus 5, 7. 7 plus 5, 12. 12 plus 5, 17. 17 plus 5, oh look, that is 22. Takes me to my last term in my sequence. Okay, let's try a couple more. So here it asks me to write an explicit formula satisfying the following conditions. Find the indicated term. Okay, so I'm told a sub 1 is 10. This means first term is 10, right? D equals negative 4. That means how I get from one number to another. I am subtracting 4. Okay, I'm asked to write the explicit formula here. Okay, so for an arithmetic sequence, explicit formula is a sub n. Any term is the first term plus your common difference multiplied by the index minus 1. Okay? All I'm going to do is plug what I have in. So a sub n equals first term. I was told first term is 10. Okay? Plus my common difference, in this case it's negative 4, multiplied by n minus 1. Okay? Then I'm going to just simplify this a little bit. Okay. So a sub n equals 10. I'm going to distribute this. Okay, so plus and negative, we normally don't write it, so it's just minus. Okay, so negative 4 times n is negative 4n. Negative 4 times negative 1 is plus positive 4. Right. Then I'm just going to clean this up a little. A sub n equals negative 4n. Let's combine like terms. 10 and 4 are like terms. They are both constants. 10 plus 4 is 14. Okay, so my explicit formula is a sub n equals negative 4n plus 14. Okay. From there, easy to find my indicated term here, right? So I want a sub 5, right? So what this means is n is 5. Okay, no problem. Just plug it in. So negative 4 times 5 plus 14. Negative 4 times 5 is negative 20. Negative 20 plus 14 is negative 6. So what this means is my fifth term, if I were to list it all, it would be negative 6. So let me show you, right? So here our first term is 10, right? To get to our next one, we subtract 4. So subtract 4, 6. Subtract 4, 2. Subtract 4, 2. Right? So minus 4, minus 4, minus 4. Right? So if I see first term, second term, third term, fourth term, fifth term, yep, it matches. I did it correctly. Okay. Let's try the next one. Okay, I'm told here first term is negative 2. Common difference is 9, which means I'm adding 9 each time. Okay. Let's write the explicit formula. Okay, so I'm going to write the general formula. Okay. A lot of the times we have difficulty remembering all this. Okay, if you write it a bunch of times, if you write it every single time you'll use it, you will remember it. Okay, so every time I'm going to use the explicit formula, I'm going to write it again. Okay. So a sub n equals my first term. My first term in this case is negative 2. Right, a sub 1. That tells me first term. Negative 2. Right. Plus d. D in this case is 9, so plus 9. Okay. multiplied by n minus 1. Multiply n minus 1. Okay, let's just clean it up a little. Okay, I'm going to distribute this 9. Okay, so when we distribute, we are multiplying. Okay, 9 times n is 9n, so positive 9n. 9 times negative 1 is negative 9. Okay, then I'm going to simplify. Okay, so combine like terms, negative 2 and negative 9 are like terms here. Okay, it's negative 11. And so here you go. Okay, please be careful how you write it. Okay, so here, this n is smaller and it's lower. Okay, versus this is at the same height. Okay, so please make sure that you write it accurately so I know that what is a subscript versus what is just multiplying, right? Because if we have things that are just next to each other, that is multiplying, right? If we have a subscript, it should be smaller. From here, let's find our 11th term. So this tells me n is 11, right? That's my index. All I have to do is plug it in. So 9 times 11 minus 11. 9 times 11 is 99. 99 minus 11 is 88. So what this means is if I were to write out the sequence, the 11th term would be 88. Okay. So let's keep going here. Okay, so given the following sequence, find the indicated term. Okay, so here, 20 to 14, I notice we subtract 6. 14 to 8, we're subtracting 6, subtracting 6, subtracting 6. So what this tells me is that my D value, my common difference, is negative 6. Okay. From this sequence, I also know my first term. Okay, my first term here is 20. It's the first number in my sequence. Okay. So then, I can now write the rule for it using my explicit formula rule, right? So any term is the first term plus the common difference multiplied by n minus 1. Okay, so since I know what the first term is, my common difference is, I can plug that in. So a sub n equals my first term 20 plus my common difference, which is negative 6, times n minus 1. So how I got everything. 20 is here. Common difference is here. I noticed the pattern was subtracting 6. Okay, so let's just clean it up. So a sub n equals 20. Okay, negative 6 times n is negative 6n. Right, we do not need to write plus a negative, it just means minus. So negative 6 times n is negative 6n. Negative 6 times negative 1 is positive 6. Okay, so a sub n equals combine like terms. Okay, 20 plus 6 is 26. Okay, so here's my rule. Okay, now I'm asked to find a sub 13. Okay, so that means I want to know which one is 13th in line. Okay. So to find that, all I need to do is plug in 13 for n and solve. Okay, negative 6 times 13 is negative 78. Negative 78 plus 26 is negative 52. So what this means is my 13th term is negative 52. So I'm going to have you try this one on your own. Okay, so try this one on your own. Come back, check your answer. Okay, so here you go. I found my first term, 15. I found the common difference. It's adding 7, so D equals 7. Then I plugged it in to my explicit formula rule to write the explicit formula. Okay, I cleaned it up. Okay, I got 7n plus 8. Okay. Since I'm finding a sub 28, I am finding the 28th term, the 20th number in this list, right? So that means n equals 28. My index is 28. So all I have to do once I have the rule is plug that in for n. Okay, and when I solved it, I ended up with 204. Okay. So we're going to finish off with some word problems. So that way you can see where do we see arithmetic sequences in real life. Right? So here we have a movie theater. Okay, this movie theater, in the first row, it has 11 seats, 11 chairs. Okay, in the second row, it has 13 seats. Okay, in the third row, it has 15 seats, right, and so on and so forth. We want to find the number of seats in the fourth row, fifth row, and sixth row. Okay, so what you should notice is from 11 to 13, from 13 to 15, what you should notice is that we're adding 2 each time, right? So from first row to second row, 11 plus 2, 13 seats now. Second row to third, plus 2, now it's 15 seats, right? So if we wanted to know the fourth row, we can just take the previous one, third row, and add 2. So 15 plus 2, that gives me 17. So in the fourth row, we would have 17 seats. If I wanted to know the fifth row, just need to add 2 more seats, I would have 19 seats. If I wanted to know what the sixth row is, I would add 2 more, I would get 21 seats. Okay. So if we were to write an explicit formula, right, let us write it. Okay, so I'm going to write the general one. It's a sub n. Any term is the first term plus my common difference multiplied by n minus 1. Okay. Again, I keep writing this so that way I will remember it and remember it and remember it and remember it. Okay. So a sub n is my first term. Okay, so my first row has 11 seats, so a sub 1 is 11. Okay. Okay. Then I'm going to find my common difference. We found it earlier. The pattern was that we were adding 2 each time. So that's my common difference. Then I just need to multiply that with n minus 1. Okay. So let's just clean it up a little. Let's distribute that 2 to the parentheses. Right. So 2 times n is 2n. 2 times negative 1 is negative 2. Okay, then let's combine like terms here. 11 and negative 2 are both constants. So 11 minus 2 is 9. 9 plus 2n, or 2n plus 9. Okay, so let me just write it. A sub n, any term is 2n plus 9. Okay. So if I wanted to find out how many seats are in the 14th row here, this tells me I want to know n equals 14. What is the 14th row? Right? So all I need to do, plug it in. Okay. So a sub 14 equals 2 times 14 plus 9. Right? 2 times 14 is 28. 28 plus 9 is 37. So what does this mean? There are 37 seats in the 14th row. And there you go. Okay. Last one. Okay. Elvin here, he's building a tower out of paper cups. Okay. In each row, from the floor up, there are 2 less cups than the row below it, right? So if you can imagine, what he's doing is he's taking cups like this, right? And then the next one, obviously, has a little less, so on and so forth. But he's doing it where it's 2 less. Right, so here I did only 1 less, but his is even more. I don't know. Okay, cool. So here, Elvin is building a tower out of paper cups. In each row, counting from the top up, there are 2 less cups than the row below it. The first row has 26 cups. How many cups are in the 11th row? Okay. So here, we're already told a sub 1, right? We're also told what the pattern is, that there's 2 less, so that means it's negative 2, subtracting 2 each time. We want to know how many cups are in the 11th row. Okay. So a sub n equals first term plus the common difference times n minus 1. Okay. Since they didn't ask us for the rule, we don't even have to simplify it fully. We can just plug in. Right. So if I want to know here the 11th row, That means n equals 11. So I want a sub 11 equals my first row, okay, 26, plus my common difference, in this case it's negative 2, multiplied by my index minus 1. Okay, if I went a little too fast, here we go. Okay, first row has 26 cups. Okay, in my formula that's here. Okay. Then the pattern, my common difference is 2 less cups each time, which means D equals negative 2. That's why we see that here. And then since I'm asking for the 11th row, that means n equals 11, and that's why I plugged in 11 here for n. Right, so now let me just simplify. 11 minus 1 is 10. Okay. 26 minus 2 times 10, 20. And then 6. Okay. So if you want, you could have done it the way we did before, where you write and have a nice cleaned up rule and then figure it out. But since here it didn't ask us for the rule, I just plugged it in directly. Right? So a sub 11 equals 6. What does this mean? This means that there are 6 cups in the 11th row. And there you go. Okay. That's it for today. Have a great rest of the day. Bye, guys.